Welcome to lesson 1. We'll start with addition and subtraction of polynomials. Addition of polynomials is simply collecting like terms together and simplifying. Alright, so this is what we did in the prerequisite video before. Now let's consider two polynomials. We have 7x cubed plus 5x squared minus 6x plus 2, and we have minus 3x squared plus 2x minus 4. Now, if we had to find the sum of these two expressions, we would write the expression like this. The first polynomial, your operation of addition, followed by the second polynomial in brackets. Now, if there was a third polynomial, we would put the operation and that one as well in brackets. Okay, now this is to ensure that we are using the correct sign in front of the term. What I mean by that is, remember your directed numbers, plus and a minus will give me a negative. So let's work this out. 7x cubed plus 5x squared minus 6x plus 2. Now, we have a plus sign here and a minus sign, and we know from our directed numbers, this would remain a minus 3x squared. We have a plus and a plus, it will remain a plus 2x. We have a positive and a negative, so we will remain as negative 4. And let's simplify. So how did we simplify in the last video? We collected the like terms together and then performed our operation. Okay, so let's rearrange. Let's start with 7x cubed. Is there any other 7x cubed? No. Our next term will be positive 5x squared. Right? We have another x squared here. It's a negative 3x squared. Then we would write this negative 6x. And there's a positive 2x here. And we have a positive 2. Our constants are positive 2 and negative 4. Our third step, let's perform the operations. So we have nothing else to do with this 7x cubed, so we'll put that back. We have 5x squared minus 3x squared, and this will give me a positive 2x squared. Minus 6x plus 2x will give me negative 4x. And positive 2 minus 4 will give me minus 2. And this cannot be simplified any further, so this is what we would leave it as. Now, if they had asked you to find the difference between these two polynomials now, 7x cubed plus 5x squared minus 6x plus 2. Now, be careful here. We have a negative sign here because we're finding the difference, and difference means to subtract or take away. So we have minus 3x squared, and this will become a positive 3x squared here. We have a minus here and a positive 2x. So the positive 2x will become negative 2x. We have a minus sign here and a negative 4. So that will become positive 4. Now be very careful with your directed numbers, with your signs in front of your terms, because this will cause you to get the entire thing wrong. And we don't want to be losing marks with these simple mistakes, okay? So be very careful. Now let's simplify by collecting like terms. So 7x cubed, we have no other x cubes, right? So 5x squared, we have positive 3x squared, negative 6x, and we have negative 2x this time, positive 2, and a positive 4 as our constants. 7x cubed, because we have nothing else to add or take away from that. We have positive 5x squared plus 3x squared, and this will give me a positive 8x squared. We have minus 6x minus 2x to give me a total of minus 8x, and positive 2 plus 4 to give me a positive 6. And we can't simplify this any further, so this is your answer. And this is how we add and how we subtract polynomials. The most important thing is getting those signs correct and computing properly. Alright, so before we move on to the other section, which is addition and subtraction of rational expressions, stop the video here and complete question 3 in section 1A algebra worksheet number 1 and check your solutions, and then move on to the next section in this video. So now that you have completed question 3, let's look at addition and subtraction of rational expressions. So a rational expression is just a fraction in which the numerator and or the denominator are polynomials. The rules for working with these algebraic fractions are the same as those used in numerical fractions. So for numerical fractions, if you had to solve a half plus 3/8, what would you do? Now, if you do not remember how to solve these, please download and revise the Fraction Facts PDF in your Google Classroom folder for lesson 1. Alright? So, what we're going to do here now is look at algebraic fractions. How would we simplify x squared divided by y minus y squared divided by x? The same process as if we were subtracting numerical fractions. So we would draw our vinculum, we would find a common denominator. In this case it would be yx or xy. Alright, so yx and xy is the same thing, okay? So here you could have yx or xy, anyone you want. Now yx divided by y will give me x, and x squared multiplied by x will give me x cubed. Okay, so here your knowledge of exponents, working with exponents and indices, x squared multiplied by x is, we assume there's a 1 here, but we know there's a 1 there, and we add the indices because they are same bases, right? So we have x cubed. Okay, our subtraction sign. Yx divided by x will give me y, and y squared multiplied by y, again the same process will occur here, and we will have y cubed. So our final answer here, to simplify this, will be x cubed minus y cubed divided by yx or the xy. Okay, and we can't simplify this any further. So there are some questions in the worksheet again. So go ahead and practice simplifying algebraic fractions and rational expressions in questions 4 and in questions 5 in algebra worksheet number 1. And then we'll move on to page 2. So now that you've finished questions 4 and 5, let's take a look at multiplication and division of polynomials. When multiplying polynomials, we multiply every term of one polynomial by every term of the other polynomial using the distributive property. When dividing polynomials, we use the same division rules as for fractions. Okay, so again, if you don't remember how to divide fractions, take a look at the PDF called Fraction Facts in your Google Classroom folder for lesson 1. Now, how do you multiply something like 3p squared qr multiplied by 4p cubed by 5qr squared? We could do something similar like collecting like terms. So let's collect all the coefficients first. 3 multiplied by 4 multiplied by 5, and then we have, let's collect all the p's. P squared multiplied by p, we have no p here, right? So it's just p squared and p. So the next term is q. We have q cubed here, and we have one single q here. The next one is r. We have no r here, but we have r squared here. Alright, so let's see what this is. 4 multiplied by 3 multiplied by 5 will give us 60. Multiplied by, we have p squared by p. So, as we said previously, when we have like bases, we add the indices, and we know there's an index of 1 here. P squared multiplied by p will give me p cubed. Q multiplied by q cubed multiplied by q. This is actually 3, 4, 5 q's there. So q to the power of 5 multiplied by r squared, which should give me r cubed. Alright, and our final answer will be 60 p cubed q to the power of 5 r cubed. Right, and this is our simplified form here. Now, when we are dividing polynomials, first thing we want to do is expand this bracket here. Alright, let's expand that bracket. So I'm going to put back the numerator. And expanding this bracket, I'll take the 3 multiplied by 4x to give me 12x. And the 3 multiplied by 1 to give me plus 3. Alright. Now if we look closely here, we could see that if I multiply the denominator by 2, I will get the numerator. Alright. So 24x plus 6 divided by 12x plus 3 is really 2. So 2 here is your answer. So now you can go ahead and practice some of these questions in question 6 in the worksheet number 1. And then we'll move on to multiplication of rational expressions. So now that you've completed those questions, let's take a look at multiplication of rational expressions. In multiplication of rational expressions, the terms may be cancelled top and bottom, just as you would do if you were reducing numerical fractions to the simplest form. If you do not remember how to solve these, please download and revise the fraction facts in the PDF document in the Lesson 1 folder in the Google Classroom. Now let's take a look at this example here. How would you simplify 3x squared divided by 5y multiplied by 5yz divided by 6x? Well, as we said above, we could start by cancelling the top and bottom, just as you would do as if you were reducing numerical fractions. Okay, so let's do that. So we have 5 here and a 5 there, so we could cancel those out. We have a y here and a y there, so we could cancel those out as well. We have a 3 here and a 6 there, so 1, 3 is 3, that's a 1, and 3 could go into 6 2 times. We have 1x here and x squared there, so this x here could go into x squared x times. Alright, so we are left with 1x, a z here, and a 2 at the bottom. So we rewrite that xz divided by 2. And that is your simplified form. Pretty simple, right? Okay, great. Now, there are questions in the worksheet again. Questions 7 and 8 is all yours to try. So please do not take these simple practice questions for granted. They will play a big role later on in lessons 2 and 3 and 4. So when you finish with that, we'll move on to division of rational expressions. So division of rational expressions. Now, depending on the type of question, you will need to know how to factorize algebraic expressions. The most common algebraic expression you will see here will be in the form of a trinomial or a quadratic. Alright, so step 1 would be to completely factor both the numerators and denominators of all fractions. Okay, so which means we're going to take the quadratic expressions and we're going to factorize them. Alright, both in the numerators and the denominators first. The step 2 will be to change the division sign to a multiplication sign and flip the fraction after the division sign. Okay, just like you would do when you're dividing fractions. Okay, Now in step 3, you could cancel or reduce the fractions. Now remember that to reduce fractions, you can cancel something in the numerator with something in the denominator. But in order to cancel something in the numerator and the denominator, the two factors must be exactly the same. Okay? So we can't cancel a x minus 1 with a x plus 1. Okay? They must be exactly the same. The expression x plus 1 must be cancelled with x plus 1 in the denominator. Alright? Step 4 will be to rewrite the remaining factor. Now, reading the steps, you're going to be confused. Alright? So let's try it with some examples, and you'll see the steps coming in, and then you'll have questions to practice on your own. And of course, you have your solutions there. Right? So the worksheets are not tests. The worksheets are for you to try and to use the notes and the videos to try the questions, and then you have your solutions there to guide you. So let's look at example 1. So in example 1, we have a quadratic at the top, we have a quadratic at the bottom, and it's being divided by another rational expression with a polynomial or a quadratic on the top and the same at the bottom. Now our step 1 said to do what? Step 1 says to completely factor both the numerators and denominators of all fractions. In our first fraction, we have x squared minus 8x plus 15. Alright, now we need to factorize this. Now, we are not going to use the quadratic equation here. Alright, you need to know how to factorize using what students like to call the AC method, where our a here is the coefficient of our x squared term, our b is the coefficient of our x term, and the c is our constant. So AC in this case would be 1 multiplied by 15, which is, and of course your sign is important, positive 15. Our b here is minus 8. Okay, not just 8, the sign in front of it needs to be included. So when we're going to factorize this, we need to find two numbers that when multiplied will give me positive 15, and when added will give me minus 8. So what two numbers we could use? 5 3s are 15, and 5 plus 3 is 8, right? But we need positive 15 and negative 8. So if I make one of them negative 5 and the other one negative 3, we will see that it will work out. Minus 5 and minus 3 will give me positive 15, and if we add them, we'll get negative 8. So let's replace our middle term with our negative 5 and our negative 3. So we rewrite x squared minus 5x minus 3x plus 15. We pull out the common factor here, which is x. We will remain with x minus 5. The common factor here is minus 3. We will get x minus 5. And simplify this further to get our two factors, x minus 3, x minus 5. Alright, now we are going to replace this here with that. Okay, so let's rewrite it here. Now we're going to repeat the process for each one of these quadratics. Okay, so your factorizing game must be good. Alright, if you're not good with this type of factorization, please practice. Okay, find an exercise or look in your textbook for the chapter on this in your maths textbook. Alright, if you didn't do it in Add Maths, you would have done it in mathematics. Alright, practice, practice, practice. And then you'll be able to master this topic here in Add Maths, right? So let's factorize now. Okay, so we finished with that one. Let's factorize x squared minus x minus 6. Okay, so our AC term here is 1 multiplied by minus 6 to give me minus 6. Okay, and my b is minus 1. So I need two numbers. When multiplied will give me minus 6, and when added will give me minus 1. We could try positive 2 and negative 3. Okay, so positive 2 plus negative 3 will give me negative 1. So let's replace our middle term here with those two numbers. So I'll rewrite x squared plus 2x minus 3x minus 6. Our common term here is x. We'll get x plus 2 in brackets. Our common term here is minus 3. I'll be left with x plus 2. And our final factorized form is x minus 3, x plus 2. And I'm going to replace that here. X minus 3, x plus 2. Alright, so now we're dividing. I'm going to put back this division sign here for now. Alright, let's get the factorization out first, and then we'll proceed with the second step. So we're still on step 1, right? We're still changing all the polynomials. We're still factorizing all the polynomials. So our next polynomial is x squared plus x minus 20. Our AC term is 1 multiplied by minus 20 to give me minus 20. Our B term is plus 1. So again, two numbers. When multiplied will give me minus 20, and when added will give me a positive 1. I could go with positive 5 and minus 4. 5 4s are 20. The plus positive and the negative sign here will give me negative 20. So I'm going to replace the middle term with those two. So I have x squared plus 5x minus 4x minus 20. The common term here is x. X plus 5 minus 4 and x plus 5 in brackets here. So my final factorized form is x minus 4, x plus 5. Now I'm going to replace this numerator here with x minus 4, x plus 5. Now our final fraction to factorize is x squared minus 6x plus 8. So two numbers that will give me positive 8, and when added will give me negative 6. We could go with negative 4 and negative 2. Okay, so x squared minus 4x minus 2x plus 8. Pull out the x, we will get x minus 4. If we pull out the minus 2, we will get x minus 4 here as well. Our final factorized form is x minus 2, x minus 4. And we're going to replace the denominator here with x minus 2, x minus 4. And that's the end of step 1. So step 2 said to change the division sign into a multiplication sign and reciprocate, or write the reciprocal or flip the fraction. So our denominator here will become our numerator, and our numerator here will become my denominator, and everything on the left hand side here remains the same. So x minus 3, x minus 5, x minus 3, x plus 2. So what does step 3 say? Step 3 says to cancel or reduce the fractions. So okay, so let's start cancelling. So do we have any x minus 3's anywhere that we could cancel with? Yeah, there's one here in the denominator. So we could cancel this with that one. Any x plus 2's anywhere? So no x plus 2's, right? So we leave that as is. Any x minus 5? No, we have x plus 5 here, but it's not the same. X minus 4, we have one here, and we have one here as well. Okay, So we are left with, so step 3 is done. We did our cancelling. Alright, now step 4 is to rewrite the expressions that remain. So we are left with x minus 5 in the numerator and x minus 2. And in the denominator, we are left with x plus 2 and x plus 5. So again, pause the video and try the question yourself or copy down the solution. Alright, make sure you understand what is happening here. And we will take a look at the next example. Okay, so example 2. So we're going to simplify again, first by factorizing. So step 1 is to factorize all these polynomials. Let's start with the left hand side. 6x squared plus 11x minus plus 3, we need two numbers. When multiplied will give us positive, 6 3s are 18, and when added will give me positive 11. So your multiplication tables come in handy here, right? And your addition skills. So 9 and 2, we could try those two. 9 2s are 18, and 9 plus 2 is 11, right? Easy enough. So we're going to replace our middle term with the 9 and 2. But it's going to be 9x plus 2x plus 3. So if I pull the 3x out here, I'll remain with 2x plus 3. Alright? The only thing I have common here with 2x plus 3 here is plus 1. And 2x plus 3 will remain in the brackets. So my final factorized form here is 3x plus 1 2x plus 3. I'm going to replace the numerator on the left hand side here with its factorized form. So 3x plus 1, 2x plus 3. Now let's factorize the bottom part, the denominator. 2x squared minus 7x minus 15. I need two numbers that when multiplied will give me minus 30. And when added will give me minus 7. So two numbers that could do that would be positive 3 and a minus 10. So 2x squared minus 10x plus 3x minus 15. So the only thing common here will be 2x. I will get x minus 5, and on this part here I will pull out a positive 3 to leave x minus 5 on the inside. So my final factorized form here is 2x plus 3 x minus 5. Alright, so I'm going to replace the denominator here with 2x plus 3 x minus 5. I'm going to put back the division sign and let's factorize the other side. So this one here is a little bit simple. From here, from your maths, you should be able to identify this as the difference of two squares. So yeah, 9x squared minus 1 is the difference of two squares. So we know that the difference of two squares, to factorize that, it's just the sum and the difference of the square roots of each term. So the square root of 9x squared is 3x, and we're going to show the difference. The square root of 1 is 1, and the sum, so 3x plus 1. So let's factorize the denominator on the right hand side. So our expression is 2x squared minus 9x minus 5. Two numbers that will give me minus 10, and when added will give me minus 9. Right? So I could go with minus 10 and positive 1. Alright? So 2x squared minus 10x plus 1, x, which is x, minus 5. 2x will remain with x minus 5 on the inside here. The only thing common to x minus 5 is 1. And I'm going to pull out, that will leave me with x minus 5 on the inside. So my final factorized form here is 2x plus 1 multiplied by x minus 5. And I'm going to replace that denominator with the 2x plus 1, x minus 5. So that's the end of step 1. Now step 2 is to change this to multiplication sign and input. So my denominator becomes my numerator and my numerator becomes my denominator. And this remains the same on the left hand side here. Now AddMaths is a lot of writing. It's a lot of working. Sometimes depending on the question you could take as much as 1 page on both sides plus maybe part of another page. The main thing in AddMaths is to remain focused and on track with what you're doing. Okay, it's very easy to make a mistake with a plus sign or a minus sign or to forget a term. So remain focused and concentrate on what you're doing. Our third step now is to start cancelling. So is there anything that is common? So we have an x minus 5 here and an x minus 5 here. So we could cancel that. I also have a 3x plus 1 here and a 3x plus 1 here. There is a 2x plus 3 here and a 2x plus 3 here as well. So, okay, so the entire left hand side got cancelled out. So what we are left with, which is what we'll do for our step 4, is rewrite what is left. 2x plus 1, 3x minus 1. And this is a simplified form of this division here of these rational expressions. So again, pause the video and take down these working. Make sure you understand what is happening here. And then try the questions in the worksheet, and I will see you in lesson 2.